In this question, I have been given a figure which is a parallelogram ABCD, and here the equation of line AB is y is equal to 3x. So the equation of this line AB is y is equal to 3x, and the equation of line AD is 4y is equal to x plus 11. So line AD has the equation 4y is equal to x plus 11. It is told that the diagonals AC and BD meet at a point E whose coordinates are 6.5 and 8.5, and I need to find by calculation the coordinates of A, B, C and D. So I need to find the coordinates of this point A, this point B, this point C and this point D. First, let's find the coordinates of point A. I know that point A is the point of intersection of this line and of this line. So I can solve the equations of these two lines simultaneously to find the coordinates of point A. Line AD has the equation 4y is equal to x plus 11. This is equation 1. And line AB has the equation y is equal to 3x. This is equation 2. Now I'm going to solve these two simultaneously. I'll substitute equation 2 in 1 and I'll get 4 times 3x is equal to x plus 11. 4 times 3x would give me 12x, and this is equal to x plus 11. Subtracting x on both sides would give me 11x is equal to 11. Dividing both sides by 11 would give me x as 1. So the x coordinate of point A is 1. Now for the corresponding y coordinate, I'll put this x in equation 2 and I'll get y as 3 times 1, which gives me y as 3. So the y coordinate of point A is 3. Now I found the coordinates of point A, so the coordinates of B, C and D are left to find. There is a property in parallelograms which states that the diagonals of a parallelogram intersect at midpoints to each other. So the distance of this line and this line are going to be the same. So the distance EC and the distance AE are going to be the same, and the distance B to E and the distance E to D are going to be the same. Now since AE and EC are equal to each other, I can say that E is the midpoint of AC. We know that the formula of midpoint is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. I know that the midpoint is point E that has the coordinates of 6 whole 1 upon 2, comma 8 whole 1 upon 2. Let's take this point as x1, y1, so I'll get 1 plus x2 divided by 2 because this point has the coordinates of x2, comma y2, comma 3 plus y2 divided by 2. This is the x coordinate of the midpoint, which is 6 whole 1 upon 2. So I'll get 1 plus x2 upon 2 is equal to 6 whole 1 upon 2. Multiplying both sides by 2 would give me 1 plus x2 is equal to 13, and subtracting 1 on both sides would give me x2 as 12. This is the x coordinate of point C. And for the y coordinate, 8 whole 1 upon 2 is going to be equal to 3 plus y2 upon 2. Multiplying both sides by 2 would give me 17 is equal to 3 plus y2. Subtracting 3 on both sides would give me y2 as 14. So the y coordinate of point C is 14. Now next I'll find the coordinates of point B. I know that B is the point of intersection of line AB, line BC and line BD. But I only know the equation of line AB. I don't know the equation of line BD, nor do I know the equation of line BC. So I can't use the method of solving equations simultaneously to find the coordinates of point B. So first I need to find the equation of one of these two lines, and then I can solve the two equations simultaneously to find the coordinates of point B. I can find the equation of line BC because I know the coordinates of point C, and I also know that these two lines are parallel to each other. So the gradient of these two lines are going to be the same. If I arrange this equation in form of y is equal to mx plus c, I'll get y is equal to x upon 4 plus 11 upon 4. So the gradient of this line is 1 upon 4. And since these two lines are parallel to each other, so the gradient of this line is also going to be equal to 1 upon 4. Now I know the gradient of this line and I know the coordinate on this line, so I can find the equation of this line now. To find the equation, we use the formula y minus y1 is equal to m times x minus x1. x1 is 12 and y1 is 14, so y minus 14 is equal to m is 1 upon 4, so 1 upon 4 times x minus 12. This gives me y minus 14 is equal to 1 upon 4x minus 3. Adding 14 on both sides would give me y is equal to 1 upon 4x minus 3 plus 14. Minus 3 plus 14 is 11, so y is equal to 1 upon 4x plus 11. This is the equation of this line BC. Now for the coordinates of point B, I'll need to solve the equation of this line and the equation of this line simultaneously. The equation of line AB is y is equal to 3x. Let's say this is equation 1, and the equation of line BC is y is equal to 1 upon 4x plus 11. This is equation 2. Now I'll equate these two and I'll get 3x is equal to 1 upon 4x plus 11. Subtracting 1 upon 4x on both sides would give me 3x minus 1 upon 4x is equal to 11. 3x minus 1 upon 4x is 11 upon 4x is equal to 11. Cross multiplying would give me the x coordinate as 4. So the x coordinate of point B is 4. Now for the y coordinate, I'll substitute this x value in equation 1 and I'll get the y coordinate as 3 times 4, which is 12. So the y coordinate of point B is 12. Now next, for the coordinates of point D, I'll again use the fact that point E is the midpoint of BD. You know that the formula of midpoint is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. The midpoint I know is point E, which is 6 whole 1 upon 2, comma 8 whole 1 upon 2. If this is x1 y1 and this is x2 y2, this would be equal to 4 plus x2 divided by 2, comma 12 plus y2 divided by 2. The x coordinate would be equal to 6 whole 1 upon 2, so 4 plus x2 upon 2 is equal to 6 whole 1 upon 2. Multiplying both sides by 2 would give me 4 plus x2 is equal to 13. Subtracting 4 on both sides would give me x2 as 9. So the x coordinate of point D is 9, and for the y coordinate, 8 whole 1 upon 2 is going to be equal to 12 plus y2 divided by 2. This would be equal to 17 is equal to 12 plus y2. This gives me y2 as 5. So the y coordinate of point D is 5. So the coordinates of point D are 9, 5. So this is my answer. We have found the coordinates of each and every vertices of this parallelogram.